Major support for Do the Math has been provided by CHEVRON, the Kern County Superintendent of Schools, EDISON International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary STROOPE Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Cindy.
And in studio with us, we have Jessica. And Jessica, if somebody wanted to get a hold of us, what would they need to do?
For math homework help, call in Bakersfield 636-4357, toll free 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net, and social media, Facebook, Instagram, Twitter, and YouTube.
Now, when you were practicing that, you said what about it? A lot of sixes?
Yeah.
There's a lot of sixes in there, right? Well, we're going to break that up right now, because why don't you let everybody know where you go to school and what grade you're in?
I go to Quellwood Elementary, and I'm in 5th grade.
Oh, good. So it's not 6th grade. All right. Are you looking forward to 6th grade next year?
Yeah.
What are you looking forward to? Like, have you heard anything about it, or
No.
you just want to get to 6th grade so you can keep moving on?
Yeah.
All right. Do you have any idea why you're here today?
So I can do my homework.
That's right. We're going to help you out doing some of your homework. And you're working on some fractions and mixed numbers and stuff, right? So why don't you and Cindy head over to the board, and we're just going to get some basics out of the way. So if we put 4 over 5 as a fraction, go ahead and write that up there. 4 over 5, 4/5. And explain to us what those numbers are, if they have vocabulary that goes with them.
Numerator and denominator.
Which is which?
The numerator and denominator.
All right. Let's put a 3, whole number 3 in front of that. All right. So now what's going on?
It's a mixed number.
Okay. So what do you know about mixed numbers?
I don't know.
All right. Well, Cindy's going to help you. What you're going to do is you're going to take that mixed number and you're also going to turn it into an improper fraction. All right. So I'll let you ladies
Do you know
go
what
to it.
improper fraction is, first off?
Not really.
Not really. So that would be, so it's improper because you don't usually leave it that way. And that's when the numerator is bigger than the denominator. Okay, so we're going to go over how to do that. All right. So before I show you just the basic, quick method. So if you just had 3 wholes, how much, could you rewrite it as something out of 5? Something fifths? What if you had 1 whole? How many fifths is it?
1 whole and 5th.
Yeah, like how many over 5 would it be the same as?
4.
So, okay, so 1 whole, right? So say you had, let's draw a diagram, right? So say you had a pizza, right? You had a whole pizza, and it's cut into 5. So how many slices are there if it's still all there?
1.
So, let's cut it. Okay, whoops, let's see. It's in 5, so it's kind of a, they have to be equal, but 1, 2, 3, 4, that's 6. Okay, so let's say 1, 2, 3, 4, 5. They're not equal, but let's say it was like that, right? How many slices are there before you eat any?
4.
Oh yeah, because I didn't do it right. Okay, hold on.
You know what? Instead
supposed
of
to be
a
5.
round pie,
There we go.
make
A rectangle.
There you go.
That would be easier because that's easier to split, right? So you just go 1, 2, 3, 4, 5. So that's 1 whole rectangle right now, and each there's 5 pieces. So 1 whole 1 is the same as 5/5. 5 out of 5. Have you learned, a number over
yeah.
itself is always 1. So if you have 3 wholes, it's like saying you have 5/5, another 5/5, and another 5/5. So that'd be how many fifths altogether?
5.
So 5 for each one. So if you had 3 of these, like, okay, so you have this. Here's another one. 1, 2, 3, 4, 5. Wait, 1,
Wait,
2, 3, 4,
15?
5. Yes, exactly. So how can we get 15 from some of the numbers that are here? Like with these 2 numbers, what could we do to get 15?
Times them.
So that's your first step to make it an improper fraction.
Oh, we did it like that and then times that.
There
and
you
then
go.
plus
See, now you
4.
remember. Okay, so you multiply and then, what'd you say?
Plus.
Yeah, sorry. Okay, so what would you get right here?
19.
Yeah. So go ahead and write it. 19 over what?
19 over 5.
Exactly. Okay, good job. So that's because this is like 15 fifths, right? And then you have another 4 fifths, which makes 19 altogether. Okay.
All right, good. So that's just the basics. We'll go on from that a little bit later on, all right? But do remember we have phone tutors available until 5:30 this afternoon. Time now for today's Math in the News. And today's Math in the News has to deal with stocks and the stock market. So, do you have a lot of stocks? You partake in the stock market all the time? Take a look at the things every day?
Yeah.
You do?
Yeah.
What kind of stocks do you have?
I don't know.
You don't know, but you have stocks?
Yeah.
Okay. So it's a good thing to keep an eye on them, right? Because you want to know, are they making money or are they losing money, right? If they're losing money, is that good?
No.
No, not unless you want to buy more of it, and then maybe you buy it at a low price and then sell it when it gets high. So anyway, we take a look at the stocks that are of local interest in the local newspaper here today. So we'll just deal with the first one, AT&T. Have you ever heard of AT&T?
Yeah.
What is that?
Like a bank?
Or a phone, right? Have you heard of the phone company AT&T?
Yeah.
Okay. So AT&T Incorporated, we can see that the first thing says high, 38.64. The low, 38.18. Now, what do you think those two numbers mean, the high and the low? And they're pretty close to each other. What do you think that means? Because every day they do this.
That they're going down and higher?
Okay, so they're going up and down, right? So for the day, the high, because stocks go up and down all day long based on how many people are buying and selling the stock, okay? So the price will go up and down all during the day. So the highest it got during the day was $38.64. The lowest it was $38.18. So it stayed pretty close, right? But it went up a few cents here and there all throughout the day. At the end of the day, when they go, all right, they ring the bell and that's the end of the day, it stopped. It ended at $38.52. Okay? Does that make sense that it would end between the high and the low? Well, if it went,
Yeah.
yeah, right, because it's got to be somewhere between the high and the low, right? It's got to stop in there somewhere, okay? So we can see it closed at $38.52. Now the last column says change, and there's no negative symbol in front of that, and it says 0.14. Do you have any idea what that might mean?
How much change they got in that day?
Okay, so it's going to be the change for the stock for the day. Now, if there's no negative in front of it, what would it be, do you think? If it's not negative, it might be
Positive?
positive, right? So if it's positive, did you make money or lose money?
Make it.
You made money, right? Okay, so since yesterday, they went up 14 cents. Okay, so here's what I'm going to have you do. I'm going to have you go over to the board with Cindy, and you're going to write down the close for the day is 38.52. All right, so go over to the board. So the close is 38.52.
Did I write it?
Yep, go ahead and write 38.52. That's what the stock closed at, $38.52. And we made 14 cents. Now, if we made 14 cents from yesterday, and we want to know what it was worth yesterday, here's the question. Do we add the 14 cents or do we take it away? You and Cindy can discuss that.
So Today it's $38.52, and that's
Is
after
an
we made
increase.
14
Right.
cents, right? So if we want to figure out yesterday's price, would yesterday's price be more or less than today's? What do you think?
Less. Or more.
Which one do you think?
More.
So,
wait,
so we made money
less?
today, right?
Yeah.
So that would mean that yesterday's was,
Less.
yeah, exactly. So what would we do with the 14 cents if we want to figure out yesterday's price?
Subtract it.
Good, yeah, exactly. Go ahead and put your decimal on there for me.
Right.
So it's 14 cents. So where would that go?
That.
Yeah,
Right.
exactly. So you lined it up exactly where it should be. So
Um.
all right. So yesterday's price was
38 and 38.
All right, so 38.38 is what it must have closed at yesterday, made 14 cents, which is why now it closed at 38.52, and that is today's Math in the News. 636-4357 is that phone number. We do have phone tutors available until 5:30 this afternoon. Time now to head out and about and visit with the friends at Bakersfield Machine.
Hey, thanks a lot, Mike. We're on the road out of the studio today, visiting businesses in town to apply what our kids are learning in the classrooms to what we still call the real world. It all feels very real to me, no matter where we are. But how does the work that you do at your school apply to how professionals handle the work in their places of business? So today we're at Bakersfield Machine Company, joined today by Patrick Goodwin, Industrial Machinist. Patrick, great to meet you, sir.
Nice to meet you.
Tell us a little bit about the work that you do with Bakersfield Machine Company.
We do a variety of stuff. We refabricate pump parts. Like as far as what I do is I repair shafts, I repair sleeves. I can make pretty much anything you need out of shafts or sleeves or you name it, we can make it.
So predominantly working in machines that support the oil industry, correct?
No. We don't work on anything really for the oil fields.
Okay.
We work on stuff for the pumping industry, places like Searless Valley Minerals or U.S. Borax. We do a lot of internal pump work, rotating pumps, cylindrical pumps, those kind of things. We rebuild a lot of pumps that make the world go around, basically.
I think there's that misconception in town that the two are one and the same.
Yeah, the two are not the same. Oil field is a little different than industrial as far as where it comes to like the type of work that we do. We work on big pump stuff, mostly all pumps.
So your job deals with predominantly taking equipment that may have been seen in the past as kind of the end of its lifetime and bringing new quality and new use to it. So,
Reconditioning it, refurbishing it.
so tell us a little bit about the process of like finding the parts that you're going to bring back to life and how you get from the beginning to the end product.
Well, a lot of it starts in our mechanic shop up the hill. We'll have our mechanics, they'll tear a pump apart and they'll say, oh, well, the shafts, bearings and seal fits are wore out and the sleeves are bad on it. Let's give it all to Patrick and let's see what he can do with it.
So you've walked us through a few of the parts that we'll explore today in our work here at Bakersfield Machine Company. We've got three main rooms. We have saw, we got spray, and I think the third one was grind, right?
Yes.
Okay, so I mean that basically walks us through the entire process from beginning to end. If we have a new part, if we have an example of a part that is getting brought in that we're going to bring back to life, how does that rebirth start in the saw room?
Well, in the saw room, if you have a part that you need to make a new part, if you say, okay, well, this part's too wore out to fix it, we start in the saw room saying, okay, we're going to find out what that material, the old part is made of, and we're going to go find it in the saw room and get the right material to match it, and we're going to cut it on our saw, and we're going to start machining it and start working on it.
Now, you know, I think a lot of our viewers have a certain vision in mind with how they think of a saw, but I mean, you have a lot of different types and varieties that you have in place for a
Yes.
lot of different types of parts.
Yes. We have a variety of metals that we use, and we can cut anything to any size up to a certain diameter. 18 inches, I think, is the biggest diameter on this saw that we can cut. But we start with any type of material that is applicable to what we're going to be repairing or making new.
So what would be the application of this device? Just on the start, we've got our wheel conveyor here, and then this is the one you said was larger, right?
Yeah, you basically have your rollers here, and it's a hydraulic saw where you can just, you lift it up with the hydraulics, you set the length that you want with a tape measure. For you kids out there, tape measures are important on a saw. You're gonna get it here and you're gonna measure with the tape measure how long your part needs to be. And that gives you a rough estimate. And then you take it from here into the machinist world, to where you go into the buildings and you start making it to the tolerances that it needs to be.
And it's interesting you mentioned the tape measures and how significant they are. You've got them clipped on right here at quick access.
Absolutely.
You know, a lot of students really think about rulers and tape measures as just kind of a general tool for, like, let's say, problem solving without really getting their hands on a lot of them. How significant is it to actually put the tool in your hands and measure it with your own eyes to get that precision?
Well, as far as with a tape measure, that's just going to give you a rough estimate. You're going to get a rough estimate off a tape measure. Once you've cut it at a certain rough estimate, you're going to take it from the saw and you're going to take it into the machine shop and you're going to really start getting the precise measurements.
So that's interesting. So the saw room here is designed just to get you down to the
started.
base of
Get you
what
started.
you can
Just
work
to get
with.
you started, yes.
And then when we move over to the next space, that's when you're going to get into the thousandths of an inch,
That's
to that
correct.
level of detail.
That's correct. And just to give you an idea, a human hair, an average human hair is 3/1000ths of an inch. For you kids out there, that's 0.003 in decimals. We deal with things that can get down to 0.0015 thousandths of an inch, hundredths of an inch. So things can get very, very technical in the machinist world as far as the mathematics go.
Well, we're going to get very, very technical with that when we visit our next room in our next segments. We're going to head over to the spray room and figure out how exactly we leverage fractions and decimals in precision for the parts that we are bringing back to new use. But for now, we're going to send it back to the studio. Mike, take it away.
All right, thanks for that, Devin and Patrick, and the fine folks over at Bakersfield Machine Company. We do have phone tutors available until 5:30 this afternoon. We also have Jessica, a 5th grade student from Quellwood Elementary, in studio working on some mixed fractions and mixed numbers and fractions in a little bit. But right now, we're going to go to the phones. And Emma, how are you today?
I'm good, thanks.
You are a 6th grade student from Reagan Elementary, correct?
Yes.
And working on a couple of exponents.
Yes, with multiplication.
As soon as you're ready, read the first problem.
Okay. 8ky to the negative 6th power.
Okay, hold on. 8ky,
Yes.
negative 6 power on the y. Yeah, okay.
Yes. And then, we'll dot them and multiply. And 7k to the negative 3rd power. Y to the 2nd power.
Y to the 2nd power?
Yes.
Okay. Is that it? Is that the
Yes,
whole problem?
that's it.
Okay. So are you wanting to simplify it first, then worry about the negatives? Or do you want to worry about the negatives, then simplify it?
I think simplify first.
Yeah, I think that's the best idea. Okay, so what would you do with the 8 and 7?
The what?
The 8 and 7? The whole number parts?
Would you add them? No, wait. Multiply?
Yeah, because they're just regular numbers, right? So they're not part of the exponent. So they're just going to do the regular math of the problem. So you're going to multiply those. So you get 56 for that part. Okay, now this is where you're worrying about those exponent rules. Okay, so what exponent is on the first k that you don't see right there?
The first what?
The k.
The y?
So you have the y to the negative 6, and then you have 8k in front of it. Correct?
Yes.
Okay, so what power would the k have even though you don't see it?
1.
Yeah, exactly. Okay, so we're going to combine our k's, right? So what do we do with the exponents for the k's when we have a multiplication problem?
Add them?
Right, so if we add our 1 with our -3, what will we get?
-2.
Exactly. Okay, so then what are we going to get for our y's when we add them?
-4.
Yeah, good. Okay, so now that we simplified it, then we have to worry about what to do with those negatives, right? So
Yes.
I'm assuming that you probably have to write it with positive exponents, correct?
Yes, positive
Oh, yeah, okay, all right, perfect. So do we need to change the 56 at all?
No.
Okay, because it doesn't have a negative exponent. Do we need to change the k?
Yes.
Okay, so what happens to it when it has a negative exponent? Do you remember?
A fraction.
Okay, so if I go to write a fraction, where do I put the k at?
The bottom.
Okay, good. And then what happens to the -2?
The negative what?
The -2, what does it change to when you put the k on the bottom?
Positive.
Yeah, okay. And then what happens to the y? Do I change it or leave it where it's at?
Change it.
Okay, so we put it on the bottom also, right? And then it becomes a +4. Now what about the 56? Where do I put it?
On
Say that again?
on the top.
Yeah, okay, because it didn't go anywhere, right? So it's technically on, it just stays on top because it's a whole number, which is kind of like 56 over 1, so it's on top. And then that would be your simplified answer. That would be your simplified answer. Do you have another one?
Okay, so for this problem, it would be like 6 over k to the 2nd power y to the 4th.
Exactly, yes.
Okay, just making sure I got that one right. I do have another problem.
Okay.
It's RG,
RZ?
G, yes,
Z is in zebra or G is in golf?
Goat.
Goat? Okay,
Yes.
thank you.
go
Okay, so RG
times 4r to the negative 4th power,
negative what power? Sorry.
4th,
Okay, negative 4th power.
G to the negative 3rd power,
Negative 4th power or 1st power?
3rd.
3rd, okay. It's kind of cutting out. All right, so is that it or is there more?
That's the problem.
Okay, so if we simplify it first, so what are the powers on the R and the G in the first part?
1,
Yeah, so each one has a 1. Okay, so then we're going to go ahead and we're going to put our R's together using the same rule we did last time. So we have R1 times R to the -4, so what would we do with their powers? Do we add
The
their
powers?
powers or do we, say it again?
add them,
Yeah, exactly. So 1 plus -4, what are you going to get?
-3,
Yeah, what happens to the 4 on the second part, the regular 4?
4,
Yeah, where do I put it?
well, it's going to become a fraction, right? So we'll just put it on the top of the fraction.
Yeah, so I'm just going to put it in front for now, but you're right, it will be on the top of the fraction. So, okay, let's go ahead and do our G's. What are we going to get for the G's when we combine them?
The G, -2,
Right, okay. And then you already told me the 4 is going to go on top of the fraction bar. Okay, so now what about the R and the G that we got now? The R to the -3rd power and the G to the -2nd.
the exponents become positive.
But where do you put them?
Oh, on the bottom.
Right, so we get R to the +3 and G to the +2. So 4 over R3, R cubed, G squared.
Yes,
Is that what you got?
yes, thank you.
All right.
All right, there you go. Some great problems right there. And for calling in today, you've got yourself a couple of tickets to go see the Bakersfield Condors. So congratulations on that. All right, we do have Jessica in studio, a 5th grade student from Quailwood, working on some mixed numbers. So over to the board, young lady, time for you to get to work. So we have 2 5/8.
All right, cleared it up. Okay, you're good.
Times 1 2/3. So explain to Cindy what you're doing, and if you need help, Cindy's right there.
Okay.
So, where do I do it? Doing
Exactly. So what are you making it into? Do you remember what it's called?
improper fraction?
Yep, exactly, improper fraction.
So you're gonna times that.
So 8 times 2,
16,
and then you add 5 to that.
21.
Okay, so just for a second, when you did 8 times 2 and you added that, that actually makes this part of
yeah.
this part. So this is gone. Okay, so this became 21 over 8, and then we need to make that one improper also.
That's
Okay, and then let's see, let me move it down a little bit so we have some room there. Okay, so now we have 21 over 8 multiplied by 5 over 3. So have you learned about like cross canceling or like reducing it diagonally at all?
no, not diagonal.
That would be
No.
of great benefit right now.
All right, yes, that's very useful. Okay, so you understand about, say, like 2/4, how to reduce it down? How to make it a lower simplified fraction? So what would you divide these both by? What can go into 2 and 4?
2.
So when you reduce it down, you get 1/2, right? So you can do that diagonally in these types of problems, okay? So if you look diagonally, so you would start with this one or this one, doesn't matter. You check. Okay, so 3 is a prime number, so you can only divide it by 3. Can you divide this by 3 also?
Yes.
Okay, so what you do is you divide that by 3, you cross it out and put what you get. So what do you get when you divide 21 by 3? So 3 times what is 21? Do you remember?
No.
So what's 3 times 5? That one you probably know, right?
15.
Okay, so 3 times 5 is 15. What's 3 times 2?
6.
So if you add 15 with 6, that will give you what 3 times 7 is.
17.
So
What?
15 plus 6.
21.
So, oh, I kind of did that backwards. I kind of told you the answer in the middle of it. So it's actually, it's 7, because you have 7, and that makes 21. I kind of did that backwards when I was trying to explain it. But so because 5 times 3 is 15, and to get to 21, you need 2 more 3s. So it's 7 altogether. Okay, so what's 3 divided by 3?
9.
Divided
that-
by, you multiplied.
1.
Yeah, so that becomes a 1. So it's like dividing them down before you multiply. It makes the numbers smaller, and you don't have to do big multiplications. Okay, 5 is a prime number, but can it divide into 8?
No.
So that way we can't change it, all right? So now you will do where you multiplied straight across like you learned before. 'Cause I saw
Do
on the
I do
paper.
it?
Yeah, go ahead. So you're gonna do 7 times 5 for the top. And then you're gonna do 8 times 1 for the bottom. Okay, so what do you know about changing that back to this type of number? Do you remember how to do that? So I'm thinking your teacher probably wants it as a mixed
Wait.
number, right?
So do I do 35 and 8 divided by something?
You are gonna divide, yeah. You're gonna divide
Divide by 3.
35 by 8. So you're gonna do this. You put the 35 inside. You're basically figuring out how many whole groups of 8 8s there are, you know? Okay, that's probably confusing you. So you divide it. So 8 goes into 35. How many whole times can it go in?
Wait. We do like 8 can't go into 3.
Okay.
So then you cross that out and then it goes. 3 times?
Okay, so 8 times 3 is 24, right?
Yeah.
What's 8 times 4? Let's just make sure. So if you add 8 to that or count 8 more up, what do you get?
32?
Will that work?
Yeah.
Okay, so you can put 4 up there. Just go with it. Okay, which equals 32.
And then I subtract it.
So what's the remainder? What's left over?
3.
Right, and so it is remainder 3, but so since we're wanting to write it like this, what you do is instead of writing it as a remainder, do you know?
You do 3 as my whole number, and then you do 4 at the top, and then 8 at the
Okay, you're
bottom.
very, very close. So this is the whole number because that's the whole amount of times it went in. So it's like a circle, 4 and that, 3 over that 8.
There you go.
Right.
So 4 3/8
exactly.
is the mixed number when you multiply those previous mixed numbers together. And for a great problem like that, you've got yourself a couple of tickets to any athletics event, courtesy of our friends at CSUB Athletics. So congratulations on that. I know basketball has a couple of games this week. Wrestling does. Swimming and diving is always going on. Baseball is starting up. A lot of things going out at CSUB. And we'll be back with more right after this. Today we're at Blake School, and we're here to Once again, we're at Blake School. We have students from 6th, 7th, and 8th grade. We've been working with a lot of numbers, looking at patterns, figuring out what mystery numbers were, place values, and now what we're going to do is we're going to work with decimals. So you know how there were ones, tenths, hundredths, right? So now we're going to have tenths, hundredths, thousandths that we're going to be looking at, okay? Can you all count up to 1?
Yes.
Yes, right? That's the number that we're going to be looking for, the number 1. All right, so take a paper, pass it down. All right, so here's the deal. You may either choose, well, let's just find 1. All right, so what I would like you to do is on your paper, I want you to find the number closest to 1 that you can make. All right, now, how many spaces do you have?
3 on each.
You have 9 altogether, right? Now look at the directions. It says you may use the numbers 1 through 9, each one once. Okay? So if I just went 1, 2, 3, 4, 5, 6, 7, 8, 9, I could do that. And then you add them up and you see if you're close to 1. Now, do you think it's going to be that simple?
No.
Probably not. Okay? So you want to get 1.000 if you can. Or if you don't even get to 1, what number would be very close to 1 in a decimal, but not 1? Do you guys know?
9. Like 0.9.
0.9, right? Now on here, instead of just 0.9, what would get even closer? Because you need 3 numbers after the decimal. So if you went let's say you added them up, can you get any closer than 0.999? You can't get any closer, can you, to 1? All right? So think about getting to 1 or 0.999 or maybe 995, or try to see if you can come up with 99 something at the end. All right? So go ahead, and what I would do is I would write kind of small in those boxes, because you think your first guesses are going to be the right ones? Probably not, right? So that way if you write kind of small, you can go, all right, well, I'm not going to use that here, or if you have an eraser, you can write as large as you want. All right? You can work together if you want. You can work separately. That's why you've all got your own papers. All right? So try to get as close to 1 as you can. Go. So you're almost through filling them in, right? What numbers do you have left? So you use 2, 3, 4, 5, 8, 9. So what do you have left?
I have 1, 7, 6.
Okay, so you have 1, 7, and 6, right? So just go ahead and put them in there because you're going to add them. It doesn't matter what order they go in. So now let's take a look at see where you're at. So you had 9, 5, and 2, and when you added those up, what did you get?
I got 16 and
Right.
15.
Right, so you got 16, you carried the 1, right? 1 and 8 is 9.
Yeah.
9 and 4,
Would be 13,
13 and 3.
15, or 14. Yeah.
13 and 3.
13 and 3 would be 16.
16, right? So just change that to a 6, carry the 1. Now what have you got?
15.
Okay, so, right, so you've got 15, right? So how do you write that now? So you're going to put the 5 there. So you have 1.566. Are you close to 1? You're a little bit over, right? 1.5, right? So we'll let the kids continue seeing how close they can get to the actual number 1, possibly even 999, if possible they can find that, with the 6th, 7th, and 8th grade students at Blake School. There you go, if that's what it is. That's what it is. If that's what it is, that's what it is.
I like the first one better.
Oh my gosh.
It's the first one.
And once again, a big thanks to the students over at Blake School. You never know what you're going to get with a bunch of 6th, 7th, and 8th graders when you pop in one day. Anyway, a lot of fun working with those students. We do have phone tutors available until 5:30. We have Jessica, a 5th grade student from Quellwood, working on mixed numbers today. But we do have another opportunity to go visit with Devin, Patrick, and the boys at Bakersfield Machine Company.
Hey, thanks a lot, Mike. Back here at Bakersfield Machine Company, joined today by Patrick Goodwin, Industrial Machinist. We're in the spray room, and we are talking a little bit about the process of bringing new life to older parts. So, Patrick, we're here to look at how you would start from a piece that you were able to kind of get down to a broader sense of what you'd like it to be, and walk us through how we get to something like this to ultimately where we'd like it to end up.
Okay, well, this obviously was cut on our saw with the first segment when we had, but what you're gonna do is you're gonna take this sleeve now with the print that you would have for it, and you're gonna set it up in the engine lathe over here like I have over here.
So give us a little bit of the specifications on this piece here. You mentioned this was about 12 pounds of stainless
About
steel.
12 pounds, half-inch wall, piece of stainless steel. Really similar to the one that I have in the machine now.
Okay.
The one that I have in the machine now is very similar to this. And what you're going to do is you're going to start by machining this to certain tolerances according to what your print gives you.
So let's take a look at some of the blueprints. There are going to be some parts of this that may or may not be familiar to some of our viewers, but specifically to the students that are starting to learn about decimals and circles, even with diameter. What could they read from this visual?
Well, what they could read here is they could say, okay, well, you start off with, you have your finish length, which is 7 inches. And that's a pretty easy thing. You cut it on the saw a little bit longer, maybe 8 inches, and then you're going to come in and part it off to size. But the decimals here that are real important are the inside, what they call inside diameter that finishes on this sleeve. And if you can see how you have only 1/1000th of an inch with your decimals here. This is calling for 3.4345 to 3.4355. Well, you only have 1/1000th of an inch tolerance on that bore right there, and that's a pretty tight tolerance considered a human hair's 3/1000th.
When we talk about tolerance, we're basically talking about margin of error. How
Yes.
far off from these measurements the final product can be to still be considered accessible and functional for what you need it
Acceptable
for.
for the print, yes. It has to, these prints have to be able to pass inspection, and you have to be able to hit the tolerances on those. And the way that you do that are with the different tooling and stuff that we have here in the machine shop to measure these as you go through this process and make a sleeve.
So this is what this piece is
This
going to
is
look like
what
from
this-
across, and then this is the top view up here.
This print right here is this sleeve right here.
Oh, okay.
Everybody, this is a sleeve that I've been working on here. Everything is finished except the OD on this gets micro finished. But the inside prints and everything on the inside is done exactly to the way that print is.
So what tools are you able to get to that precise tolerance?
Very good question.
Yeah.
The tools that I have over here, you have a variety of tools. You have your micrometers. You have mostly outside micrometers, inside micrometers, and veneers, which we call veneers here will get you the overall lengths, the micrometers, inside and outside, will get you the measurements of your inside and outside.
So you're going to use a different tool based on whether you need to measure the outside diameter
Or the
of a sleeve
inside,
or
correct.
the inside for that piece there.
Correct.
Interesting. So what's helpful with these tools, and I don't know if a lot of students would have experience or exposure to these, because I think generally they think of measurements as, okay, I'm going to get a ruler, I'm going to get a tape measure.
Correct.
These are designed to give you more precise measurements beyond simply what's marked on each of these.
Exactly. These will give you precise measurements. This sleeve here is the one we have in the engine lathe right here, right now. And what I mean by precise measurements is you're going to have to go in here and measure the outside, where if you look at the print's calling for 4.250 to 4.248 on the outside diameter.
Right.
And we use this micrometer to measure the outside.
And that's able to measure up to the thousandth.
The 1/10 of a thousandth of an
Oh, my
inch. And let me show you what that means, what we mean by a 1/10 of a thousandth of an inch. On a micrometer, everything is done in 25 thousandths of an inch. This is a 3-inch micrometer. If I go all the way down to the very bottom, and I line up my lines, this is 3 inches exactly.
Now, if you're going to need to get something smaller than 3 inches, you're going to need a different tool.
Exactly. I have another tool which is 2 to 3. Micrometers come in all different sizes. You can get them from very small to 0 to 1, all the way up to 40 inch, very high.
And each one is designed to get precision within a certain range.
Exactly.
So this would be 3 to
Now,
4
with
inches.
this micrometer, it also reads in 1/10 of a thousandths of an inch, which is your 4th decimal spot. If you kids
Right.
understand that, it's your 4th decimal spot. These little lines right here on the micrometer read in 1/10. All these here. For each revolution is 25 thousandths of an inch. So if this measures at 3 inches, let's say I want to go to 3 1/4 inches. I want to go all the way up to 3.250. So I'm going to line up my lines to 3.250. Now that actually measures exactly 3.250.
That's remarkable. So we're
And that's
able
how
to
we
get
use
within
like micrometers like this in the machine shop world. Now we have to use these micrometers, which are called an internal micrometer, to check with these micrometers. So we'll get a measurement. If I wanted to come in here and get an actual measurement of this as I'm working on it, I will come in and I will get a measurement of it as I'm boring it out and working on it. And then I will bring it over here and I will measure it with this, and I'll measure it.
So that's phenomenal. So that inner micrometer is used in pairing in conjunction with the outer
With the
one.
outside to get your precise measurements. Now, this is just a small part of the machine world. We also have the veneers that we work with too, and the veneers, like I have over here, these big veneers, if I'm looking to get the actual overall length, these are a big set of veneers that go up to 24 inches.
That's phenomenal.
Well, let's say on my print's telling me that it finishes, if you kids look here, 13.125, okay? Well, I just got done parting this off, but I have to go a little bit, I have a little bit more left to take off. So if I want to measure it, I'm going to get in here and measure it. I'm going to measure it. And if you look at this, if you do the inches, here's 1 inch, 2 inch, 3 inch, 4 inch, all the way up to 13 inches. 13, there's my first line at 100. I have 135. It should finish at 125. So I have 10 more thousandths to come off that face until I'm right to the length to finish it.
It's the tools that help you get the job done.
Yes.
So when we come back, we're going to step on over to the grind room and wrap up this process here at Bakersfield Machine Company. But for now, we're going to send it right back to the studio. Mike, take it away.
All right, thanks for that, Devin. As a reminder, we do have phone tutors available until 5:30. We have Jessica in studio, a 5th grade student from Quailwood. Right now, we're going to go to the phones. And Logan, how are you this afternoon?
Good, how are you?
I'm wonderful, thank you. You are working on some probability, correct?
Yeah.
All right, let's hear that problem.
Okay. So it is In each round of a game show, a contestant answers a multiple choice question that has 3 answer choices. The contestant advances to the next round by answering the question correctly. What is the probability of advancing to the 7th round if the contestant randomly guesses the answer to each question? Write your answer as a fraction in simplest form.
Okay, so you need to know when they'll get to, if they'll get to the 7th round?
Yes.
Okay.
The probability of advancing to the 7th round is.
Okay. So basically, how many rounds would they have to pass to get to the 7th round?
6.
Right, so we really need to figure out what's the probability that they win 6 rounds, right? Because that will tell us if they make it to the 7th round. Okay, so they have 3 answers to choose from. So what's the probability for 1 round for them to get the right answer, if there's 3 answers to choose from?
1.
Out of?
3.
Right, okay. So now, have you already worked on when you're doing compound probability, when you're doing more than 1 probability in a row?
No.
No? Okay. So each time, so when we want to know, okay, if they won the first round and we want to determine if they're going to win the second round also, what you do is you multiply those probabilities together.
Oh, okay.
So you're going to go 1/3 multiplies with another 1/3 because they still have 1 out of 3 chances to get past that 3rd round, or 2nd round, sorry. Right? Okay, so how many rounds do they need to win? We just said how many?
They need to win 6.
Okay, so, because your question only asks for them to advance to the 7th round, right? Not to, okay. So then what we're going to do is we're going to multiply 1/3 times 1/3 times 1/3 6 times. We're going to have basically 1/3 to the 6th power. Okay. Does that make sense why there's 6 of them?
Yeah.
Okay, so you guys are solving it, I assume, right?
Yeah.
Okay, so you're really just gonna multiply, okay, all the 1s together would still be a 1, right? Okay, so then you have to figure out what 3 to the 6th power is, or 6 3s multiplied together.
Right.
And here's an easy way to do that. Instead of going 3 times 3 times 3 and keep on doing that, what's 3 to the 3rd? If you just do the first 3, what will you get?
You
3?
would get 27.
Right, and the other 3 is going to be 27 also, right?
Right.
So you just go 27 times 27.
Okay. Then you'd get 54.
Well, if
That would
you
be
add
adding.
them, but you're going to multiply them.
Right. So 27 times 27 is
Right.
729.
There you go.
Okay, so the probability that he'll win 6 rounds is 1 out of 729, which would advance him to the 7th round.
Does that help you out,
Right.
Logan? All right. Well,
right.
thanks for the phone call and for calling in today. You've got yourself a couple of tickets to go see the Bakersfield Condor, so congratulations on that. All right, young Jessica, you ready to get back to work?
Yeah.
All right, back to the board. Let's take another look at one of your problems. So you have 2/3.
Hold on, it's not working.
There you go.
There we
All
go.
right, 2/3 times 4 1/5.
Okay, so do we have to change this one?
No.
It's already just regular fraction, right? Well, what do we have to do to that one? Yeah, so that one you can just rewrite it or keep it the same. So we have 2/3. Okay, so what do we have to do this one?
Turn it into an improper fraction.
Good. Okay, so 5 times 4, and then add 1. All right, so now here's your problem, right? Whoops. Okay, so then we want to see if we can cross reduce or cross cancel, right? Simplify diagonally. So if we look this way, can 2 divide into 5, or can you make 5 out of 2s? Okay, what about 3 and 21?
Yes.
How many 3s make 21? Or 3 times what equals 21?
6,
Close.
7,
53.
Okay, so you would cross the 21 off. And what do you put?
7,
Right? And then what do you put on for 3?
1.
Good. Okay, now what?
You
So what kind of problem do we have? What are we doing? What's this?
multiply.
Yeah. So we just need to multiply our tops, our numerators. I keep calling them tops. That's not the right word. Multiply our numerators. So 2 times 7.
14.
Good. All right. And then our denominators, we have a 1 and a 5.
Oh.
Yeah, 1 times 5. You did it right.
Oh, yeah.
Okay, now what's wrong with that, though? How should your answer look? Do you want to keep it improper, or do you want to make it a mixed number?
A mixed number.
Yeah, so that's like the last one we did. We need to divide it out. So you're going to do a division. I'm trying to give you room, but okay. So maybe do it over here so you have more room. So which one do you put inside?
14
Good.
and 5 out.
Mm-hmm. Okay.
You can't do 5 and 1.
Right, because 1's smaller than 5.
You can't do 5 and
5 can't make 14 exactly, but what's the closest you can get without going over? How many 5s could you use without going over?
2.
Good.
10.
Mm-hmm. Okay, so this is where it changed, right? You don't write remainder anymore. Now you have to write it as a mixed number. So do you remember which part's the big number, the whole number?
So it's not a remainder?
We don't write it as, well, because it is a remainder, but you're writing it as a fraction. You're writing it, the remainder becomes a
So
fraction instead of writing the word
you
remainder
would
with
put
the R.
2 as your whole number,
Good. Because that's how many 5s you could
and then
use.
4 as your top,
Good.
and then 5.
Yep, exactly.
That's my answer.
Mm-hmm.
There you go, nicely done. We'll leave that on the board. That way you can put it on your homework here, so there's proof that you did it right there. Nicely done, and it just takes a little bit of practice working with the mixed numbers to get the hang of it a little bit more, right? Well, congratulations on that one. You've got yourself a meal courtesy of our friends at Grillenberger. So nice work on that, but we're going to continue working on your homework, so you keep on working on that one right now. We'll help you out because we have one last opportunity to head out to see what Devin and Patrick are doing at the Bakersfield Machine Company.
Hey, thanks a lot, Mike. Back here at Bakersfield Machine Company with Patrick Goodwin, Industrial Machinist, wrapping up our pathway, our journey to giving new life to old parts. So we started off in the saw room, we made our way through the spray, and took a look at how precision measurements can be taken with micrometers. And that brings us to the grind shop where we actually are able to get that final finish to it. Now,
Correct.
you mentioned to us that, we really live in the realm of the thousandths of an inch, the 10,000ths of an inch. And so
Correct.
when we get to this machine here, this part of the process, we have to constantly check to make sure that we're on that pathway using
Exactly.
the most precise of measurement tools.
Correct. What we have here is we have what they call a grinding gauge. And for a lot of you kids out there, it starts with your basic ruler here. This will actually rotate up and down, and you have your different sizes that you have, but it starts with a measurement here for a ruler. Let's say on this last piece, I was almost at 4, actually reads 4 1/4 of an inch, 4.250, which is 1/4 of an inch. That was my starting point. Once I started to set my job up and I had it in this grinder, I had to set my dials here once I laid this part on the sleeve itself. And I had to take my micrometer, which is my measuring tool, and I measured where I was at on the size. And then once I did that, I came over here and I set my dials here to where my dials worked exactly where I set them.
So you're able to set that using the left hand there? You've got a gauge? Or
Yes, I have,
okay.
what I have is this piece right here is the actual jewel, the diamond jewel that's in there that actually will take that, and I can set it right here to adjust. And you have 2 different circles here. And for you kids to kind of understand it, if I was to come right up here at the top at 0 here, and I'm at the 1 there, that would tell me I would have 10 thousandths. So let's say I mic'd my part, and I had 10 thousandths to come off of it. This is how I would set it. I would set up the small 0 at the 1, and the big 0 at the 0, the needle at the 0, and that would tell me about right there, that's 10 thousandths to come off. So for each one of these little lines that are in here, you're dealing with 1/10 of a thousandth of an inch. So I'm going to move that needle real slow, and that's how you're dealing. If I was to be removing and grinding metal off until these zeros line up to hit the size I want to be at. So right there would be size.
So for some of our students that might be starting to explore scientific notation or exponential value with base 10, like we think of 1,000 as 10 to the third or 10,000 as 10 to the fourth. We're talking 10 to the -4th.
Yes.
It's going well below that realm of what's visible just with the naked eye. You've got to be able to use the tools to constantly check back and forth and calibrate to make sure you're at the right accuracy.
Correct.
So once we have that, we're able to put our sleeve here onto this part, and then we start grinding up with this wheel.
Yes, what we do here is we put our sleeve in here, and we've taken this chuck, and we tighten these jaws down with this wrench. And then what we have here is we have an indicator. And before we do any of this grinding with this, we have to indicate that part in right here. And this thing goes back and forth, but you have to set your part in here, and you have to indicate it to where it's really round, where this dial indicator, where nothing is moving on the dial indicator. Now we're set up to do the grind work with this. Now we go to this and we say, okay, we're going to take that metal off and get it right to the size we need to be. This right here is called a chuck, and this is called a center. This moves along with this, and they keep it nice and true and square.
And they rotate at the same rate?
Yes, they rotate at the same RPMs. I have a dial on here that I can adjust my speeds. And this thing will move real slow, and this is my diamond grinding wheel, and it will come in here and it'll grind. As I grind, I can keep miking it with the micrometer to get me the size I need to adjust to here to get it right to the precision of an inch.
It's a game of thousandths, and Patrick, I appreciate you having us by, and to share our gratitude with having you in and bringing Do the Math to your company today. We want to thank you with our traditional Do the Math tile
thank you.
on behalf of the program.
Awesome, thank you.
Thank
you very much.
Lots of really refined work down to the thousandths here at the Bakersfield Machine Shop. Mike, for the last time today, we'll send it back to you in the studio.
All right, thanks for that, Devin, and also a big thanks to Patrick over at Bakersfield Machine Company for teaching us a little bit about those micrometers and all of the different tools and how precise they need to get when they are taking care of all those tools and things that they're producing, making, and things like that. So down to the nearest 100th of an inch and things like that. So lots of very specific numbers that they're using over there. We would like to say thank you to Jessica, a 5th grade student from Quailwood, for coming in today. Did you learn a little bit more about mixed numbers today?
Yeah.
Good. That was the goal. You got some of your homework done, and we'll help you out with a little bit more if you want, all right? Did you have fun today?
Yeah.
Good. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by CHEVRON, the Kern County Superintendent of Schools, EDISON International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary STROOPE Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.